This video has been produced for the technical service training of the bus roof-on air conditioning system. In the roof-on air conditioning system, the engine drives the compressor by a belt, evaporator, and the condenser are installed on the roof of the bus, and the fan and blower are driven by electrical power. The roof-on air conditioner is excellent in the NVH, almost free from vibration and noise compared to the sub-engine air conditioner. Accordingly, it has less maintenance costs since it doesn't have a sub-engine. From now on, we'd like to explain the operation logic and service procedures of the roof-on air conditioner which is applied to the bus. The contents are as follows: system layout, components, analysis of the schematic diagram, service points, troubleshooting. First, the system layout. The system layout of the roof-on air conditioning system is shown on the screen. The cooling system consists of four major components: compressor, condenser, expansion valve, and evaporator. The compressor compresses and supplies refrigerant to the air conditioning system. Low temperature, low pressure gas refrigerant converted into high temperature, high pressure gas refrigerant through the compressor. The condenser discharges the heat absorbed from the evaporator. Then the refrigerant transforms to liquid from gas. The expansion valve drops the pressure and the temperature of the refrigerant by expanding it to help the refrigerant evaporation. In the evaporator, the refrigerant evaporates into gas from liquid by absorbing the heat energy inside the bus. Then the inside temperature cools down by the evaporation potential heat. In addition, receiver tank, a dryer, sight glass, condenser fan, evaporator blower, and so forth are installed for the roof-on air conditioning system. The components. The roof-on air conditioner consists of a compressor, evaporator unit, condenser unit, control panel, and operation panel. First, let's take a look at the compressor. The compressor pulley is connected to the crank pulley by a V-belt, and the V-belt delivers engine power to the compressor. A magnetic clutch is installed at the compressor pulley. The magnetic clutch turns on and delivers engine power to the compressor when the air conditioner is on. A sight glass is installed on the compressor block to check the lubricant oil quantity. A low-pressure switch is installed on the compressor suction pipe, and a high-pressure switch is installed on the discharge pipe. As safety devices, low and high-pressure switches sense malfunctions of the air conditioning system by pressure and stop compressor operation by turning off the magnetic clutch and turning on the warning lamp. Now, let's discuss the evaporator unit. The evaporator unit consists of an evaporator, expansion valve, blower, and sight glass. A diaphragm is installed at the upper part of the expansion valve. The diaphragm upper chamber is connected to the sensing bulb. and the diaphragm lower chamber is connected to the outlet of the evaporator. The pressure at the diaphragm upper chamber changes with the temperature changes in the evaporator outlet, and accordingly the amount of refrigerant supplied to the evaporator is controlled by the ball valve operation. A sight glass is installed inside the evaporator unit. It can be checked inside the bus. It's very useful when checking the amount of refrigerant. Next, let us explain the condenser unit. The condenser unit consists of a condenser, condenser fan, receiver tank, dryer, and service valve. The receiver tank stores and stably supplies only liquid refrigerant to the expansion valve. A fusible plug is installed on the receiver tank. When the high pressure switch is defective and pressure increases due to an air conditioning system malfunction, there is a risk of explosion of vulnerable parts. A fusible plug melts in this case to protect the air conditioning system by discharging the refrigerant. The fusible plug is a bolt type and can be replaced by simply turning the fusible plug after removing the cause. There are two types of dryers. In one, the internal desiccant can be replaced. In the other type, the desiccant cannot be replaced. The control panel is for controlling the air conditioner and displays the operation status. Therefore, various switches and lamps are installed for this purpose. Most of all the electrical components of the air conditioning system, fuses, thermostat, blower relays, condenser fan relays, compressor relay, and so on, are located on the operation panel. Next, we would like to explain about the roof-on air conditioning electrical system by using a simplified schematic diagram. First, let's learn about the power supply control. Since the bus roof-on air conditioner has large current consumption, power is supplied only in the engine running condition to prevent discharging the battery. Power supply controls in the bus roof-on air conditioner can be classified into three types: direct control type, positive control type, negative control type. This screen shows the circuit diagram of the direct control type. Before engine start, positive current is waiting at the air conditioner relay. When the engine starts, the N terminal of the alternator outputs 12 volts. Then it passes the excitation coil of the air conditioner relay and gets grounded. The air conditioner relay is on, and standby current is supplied to the operation panel's power terminal. This screen shows the circuit diagram of the positive control type. When the engine starts, the N terminal of the alternator outputs 12 volts. Then it waits at the air conditioner power switch. When the air conditioner power switch is turned on, standby current gets grounded after passing the excitation coil of the air conditioner relay. The air conditioner relay is on, and standby current is supplied to the operation panel's power terminal. This screen shows the circuit diagram of the negative control type. Before engine start, positive current is waiting at the air conditioner relay. When the engine starts, the N terminal of the alternator outputs 12 volts. Then, it passes the excitation coil of the air conditioner relay and waits at the evaporator blower switch. When the evaporator blower switch is turned on, standby current gets grounded. The air conditioner relay is on, and standby current is supplied to the operation panel's power terminal. There are positive control and negative control type evaporator blower motor controls. This screen shows the positive control type, which controls positive current to the motor. When the power supply condition is met, power is supplied to the operation panel from the air conditioner relay, and the supplied power passes the excitation coil of the evaporator relay and gets grounded. Then, power is also supplied to the switch terminal of the evaporator relay and waits. The evaporator relay turns on, and the motor operates by supplying positive current to the blower motor. This screen shows the circuit diagram of the negative control type, which controls the motor ground. When the power supply condition is met, power is supplied to the operation panel from the air conditioner relay, and supplied power passes the excitation coil of the evaporator relay and the evaporator blower switch, and then it gets grounded. At this moment, power supplied to the blower motor waits at the switch terminal of the evaporator relay too. The evaporator relay turns on, and the blower motor operates by grounding the standby current at the evaporator. The blower speed control types of the roof-on air conditioning system can be classified into 3 types: voltage control type, resistor control type, motor on-off type. Now the circuit diagram of voltage control type is shown on the screen. In the case of blower high speed, the circuit is composed in parallel, where power of 24 volts is supplied to the blower motor and it rotates at high speed. In the case of blower low speed, the circuit is composed in serial. Dropped voltage power is supplied to the blower motor and it rotates at low speed. The circuit diagram of the resistor control type is shown on the screen. In the case of blower low speed, power is supplied to the blower motor through 2 resistors, and the motor rotates at low speed. In the case of blower medium speed, power is supplied to the blower motor through 1 resistor, and the motor rotates at medium speed. In the case of the blower high speed, power of 24 volts is supplied to the blower motor without passing the resistor, and the blower motor rotates at high speed. This screen shows the circuit diagram of the motor on-off control type. When the low switch is on, 4 blower motors operate. When the high switch is on, 2 additional blower motors operate. Blower airflow is controlled by the number of blower motors in operation. Next, let's move on to the condenser fan motor control. This screen shows the condenser fan motor control circuit diagram. Power is supplied through the air conditioner relay, and it waits at the switch terminal of the condenser fan relay and air conditioner switch. When the air conditioner switch is turned on, standby power is inputted to the thermostat. The thermostat compares the temperature sensor value with the temperature setting value. And supplies positive current to the condenser fan relay when the required temperature is lower than the inside temperature. Then, the condenser fan relay turns on, and standby power is supplied to the condenser to operate the fan motor. Now, let's learn about the compressor magnetic clutch control. The control circuit diagram of the compressor magnetic clutch is shown on the screen. Power, supplied through the air conditioner relay, waits at the switch terminal of the compressor relay and air conditioner switch. When the air conditioner switch turns on, standby power is supplied to the thermostat. The thermostat supplies positive current depending on the temperature setting value and the temperature sensor value. Power is supplied to the excitation coil of the compressor relay through a high-pressure switch and a low-pressure switch. Then, the compressor relay turns on, and standby power is supplied to energize the compressor magnetic clutch, and the compressor does the work. Lastly, we would like to explain the auto stop for safety function. When the air conditioner has a problem, it stops the compressor operation. Let's analyze the circuit. When the high pressure line is too high or the low pressure line is too low, the high pressure switch or low pressure switch opens, and then power supply to the excitation coil of the compressor relay stops. The compressor relay turns off, and power supply to the compressor magnetic clutch stops, and accordingly, the compressor stops at last. However, the condenser fan operates normally. Next, we would like to explain the service points. First of all, we would like to remind the drivers of the following cautions. When the warning lamp turns on, you must turn off the air conditioner, or the magnetic clutch may be damaged due to repeated on and off magnetic clutch operation. When the air conditioner is turned on immediately after the engine starts, do not race the engine in idle state, nor accelerate suddenly, or the compressor may be damaged. Be careful not to fall down when working on the roof. Use a ladder, and the ladder must be fixed when using it. Be sure to wear safety shoes to prevent slipping. Make sure to turn the safety switch off when working on the engine room. In air conditioner maintenance, periodical checks are very important for preventive maintenance. Periodical checks can be divided into daily, weekly, monthly, and seasonal checks. In this chapter, we'd like to focus on some important parts of periodical checkpoints. Please refer to the periodic checkup table in the shop manual for more details. The air filter check is the most important one of the periodical checks. It should be cleaned every week. To clean the air filter with compressed air, blow the air in the direction which is reverse of the airflow direction while the air conditioner is working. Then remove dirt with warm water and neutral detergent, and install the air filter after it's dry. Belt tension is also an important maintenance point. Belt tension should be checked every week, and it should be adjusted as follows in case of abnormal condition. Check the amount of deflection when the middle of the compressor or crank pulley and idle pulley is pressed with the force of about 10 kilograms. If the amount of deflection is out of specification, loosen the idle pulley nut and adjust the idle pulley so that the amount of deflection is within specification. Check the compressor magnetic clutch every week. First, check whether the magnetic clutch operates with the on and off operation of the air conditioner switch. If the magnetic switch fails to operate correctly, check for any electrical failure. Check the magnetic clutch clearance with a filler gauge. Low refrigerant causes poor cooling performance. Check the refrigerant every week. The refrigerant amount can be checked through the sight glass after turning on the air conditioner. When there is enough refrigerant, you'll see no bubbles in the sight glass. A few bubbles means that there is insufficient refrigerant. Many bubbles means that there is very insufficient refrigerant. Keep the following in mind when checking. When the ambient temperature is low, a bubble can be seen sometimes despite normal refrigerant quantity. Therefore, check the refrigerant level when the ambient temperature is above 20 degrees centigrade. When engine RPM changes rapidly, bubbles can also be seen despite normal refrigerant quantity. So keep the RPMs at 1,100 when checking. When the refrigerant lacks after driving for a long time, refill the refrigerant and drive, because there's a tiny leak in the system. However, if the refrigerant lacks again soon, find the leaking point for repair, because it means a serious refrigerant leak. Since the serious leaking points are polluted with refrigerant and lubricant oil, it can be easily found by eye check. As for the leakage check, check the fitting and welding points first. Compressor lubricant oil is very important for the smooth operation of the air conditioner. Check the color and quantity of the lubricant oil every month through the sight glass. For the proper quantity, check whether the lubricant oil level positions at the 2/3 position of the sight glass. Refill the oil when it becomes low, and don't forget to check the oil level when replacing any components. We can diagnose the malfunction with the lubricant oil color. If the lubricant oil color is black, the compressor should be checked for any problem because the color could be changed by carbonization. If it is silver in color, journal parts of the compressor connecting rod could be worn out. In this case, check the compressor. If the lubricant oil is milky in color, water might be mixed in the refrigerant. These cases usually happen in case of mistakes in service operation or insufficient vacuum operation. Since it's liable to happen on a rainy day, do not work on the refrigerant line on rainy days. When the lubricant oil color changes, find the relevant cause and repair it. Then replace refrigerant, lubricant oil, and dryer, and perform cleaning operation. The cleaning operation is for removing any impurities remaining in the refrigerant line. As for the procedure, repeat dryer replacement 2 or 3 times after air conditioner operation. If the air conditioner gets cool enough, we may judge that impurities have been removed. When the refrigerant line is polluted, the dryer may be clogged. Dryer clogging can be checked by the temperature difference between the inlet and outlet pipes by hand. The temperature should be the same. If you can feel the temperature difference, replace the dryer. The dryer is a monthly check item. The sensing bulb of the expansion valve should securely contact the pipe and should avoid contacting the air. The expansion valve should be checked every season. Check the connecting points of the pipes and replace the expansion valve when the connecting point of the sensing bulb is damaged. Pump down means to move all refrigerant in the low pressure side to the high pressure side. Using this operation, we can repair or replace the compressor, evaporator, expansion valve, dryer, low pressure sides pipe and hoses without removing the refrigerant. The pump down procedure is as follows. Installed manifold gauge. Remove the low pressure switch connector and directly connect the low pressure switch's harness side terminals. Close the service valve at the receiver outlet completely. Loosen the low and high pressure service valve by turning the valve stem 2.5 turns clockwise. Start the engine and operate the air conditioner. And then push the accelerator pedal until the low pressure gauge reaches 0.1 kilogram per square centimeter. As soon as it reaches 0.1 kilogram per square centimeter, you should stop the engine. In this condition, no refrigerant is in the low pressure line. Repair or replace the low pressure side's components. After the work, vacuum the low pressure line. Lastly, remove the manifold gauge and then open the receiver tank service valve and close the low-high pressure service valve and reconnect the low pressure switch. When you service the air conditioning system, pay attention to the following things. Do not charge the nitrogen gas more than 15 kilograms per square centimeter when nitrogen is used for the leakage test. There is a risk of explosion when overcharged. When charging refrigerant, maintain 1,100 RPMs and charge the gas state refrigerant through the low pressure side port. If the refrigerant charging method is wrong, serious compressor malfunction can be resulted. Do not adjust the expansion valve. In particular, it is wrong to adjust the expansion valve because of poor cooling performance. We should find the correct cause for that. Do not transform the pipes or the hoses. Transformed pipes can cause poor cooling performance due to the resistance of refrigerant flow and may result in a crack after all. Be careful not to damage the pipe when drilling. If the pipe is damaged and leaks, it's very difficult to find the leaking point. Therefore, prevent any pipe damage in advance. At last, we would like to explain troubleshooting and common problem types of the roof-on air conditioning system. When the warning lamp turns on, or the customer complains about cooling performance, diagnose the problem by using a manifold gauge. The checking procedures are as follows. Install the manifold gauge to the low pressure line service port and high pressure line service port. Start the engine and turn the air conditioner on and set the blower speed at high position. Run the air conditioner for over 5 minutes at 1100 RPMs and then read the scale of the manifold gauge. When the ambient temperature is 25 degrees centigrade, it is normal if the high pressure gauge is at 13.0 to 18.5 kilograms per square centimeter, and low pressure gauge is at 1.4 to 2.9 kilograms per square centimeter. Though normal pressure may vary depending on the ambient temperature and humidity. If the ambient temperature is high, low pressure is almost no change, but high pressure increases slightly. If the ambient temperature is low, the low pressure gauge doesn't move, but the high pressure decreases slightly. When high pressure is too high, check the following: condenser motor malfunction or reverse rotation, condenser pollution, overcharging refrigerant, external air flows into the evaporator unit, excessive refrigerant oil. When low pressure is too low, check for the following: insufficient refrigerant, dryer clogging, expansion valves get clogged, evaporator air filter contamination or freezing, evaporator blower motor malfunction. When the low pressure is higher than normal pressure and the high pressure is lower than normal pressure. In this case, insufficient compression of the compressor is the major cause. This video has been produced to cover all kinds of bus roof-on air conditioning systems. So please refer to the workshop manual or the owner's manual for the detailed information depending on the model and manufacturer. We hope this video will be helpful for your service activities. We promise to bring you better contents next time. Thank you.